Today I'm going to show you how to complete 1 and 2 sample proportion hypothesis tests in Microsoft Excel. So the first problem says that it is known that approximately 10% of the population is left-handed. We have a sample of 730 Michiganders, which results in 60 people who are left-handed. Suppose you are interested in whether or not the proportion of left-handed individuals is different in Michigan than in the population at large. We are to test this hypothesis at the 0.01 level of significance. Alright, the first step in this process will be to set up our null and alternative hypotheses. So if we look closer at the question, we'll notice that it says that suppose you are interested in whether or not the proportion of left-handed individuals is different in Michigan than in the population at large. So this wording here is different from suggests that we have a two-tailed test, meaning the null hypothesis is going to be equal to 0.1, which was the percentage. And the alternative hypothesis is that it is not equal to. So I'll use slash equal to 0.1. Alright, the next step will be to go into our cells over here and input the relevant information. So the three orangish pink cells that we have over here will be information given in the problem. So first we have n, which is the number of observations or sample size. So that was the 730 Michiganders. X is the number of successful outcomes, so that would be the number of people who were left-handed from the sample, which is 60. And then next is p sub 0, which is the hypothesized value of the population proportion. And that's going to come from the hypothesis right here, or it's also the 10% that was given in the problem. So 0.1 or 10% for p sub 0. Alright, next in the white cells we will enter in formulas to calculate their values. So first q sub 0 is 1 minus p sub 0, so I'll enter equals 1 minus, and then click on p sub 0 and press enter. Next, p prime is equal to x divided by n, so I'll put equals, click on x, divide by n, and press enter. And then finally the z-score is equal to, now we're going to need to do parentheses for the top part of the formula here, and that's p prime minus p sub 0, close parentheses, divide by, now we have a square root on the whole denominator here, so we'll start that with sqrt for the square root formula, open parentheses, and then it is p sub 0, so I'll click on p sub 0 times q sub 0, and then divide by n. Close parentheses, press enter, and there's our z-score of negative 1.6. Alright, from there we can calculate our p-value, which when you have a two-tailed test with equal to and not equal to, if your z-score is negative, then you have to take equals 2 times the left tail probability. So 2 times norm.s.dist, that's the formula that gives us left tail probability. And then click on the z-score, comma, and enter true for the cumulative distribution. Alright, now if the z-score was positive in a two-tailed test, then we would have to take 2 times 1 minus norm.s.dist, meaning 2 times the right tail probability. But in our case we had a negative z-score, so we can just take 2 times this function here. Alright, so I'm going to put this value over here. The p-value is equal to 0.10875. And I need to compare that to the level of significance, which was equal to 0.01. That was given in the problem right there, 0.01. So we can see that the p-value, 0.10875, is greater than the level of significance. So when the p-value is greater than the level of significance, we fail to reject the null hypothesis. So we are not going to reject the null hypothesis here. And what does this mean in words? We need to have a conclusion statement to explain our results here. So the conclusion statement would be that at the 0.01 level of significance, there is not enough evidence to state that the proportion of left handed individuals in Michigan is different from 10%. So we did not have enough evidence to suggest that the population proportion of individuals in Michigan was different from 10%. So we're going to stick with the null hypothesis. All right, moving on to the two sample proportion case. This example says that we have a bank that has recently acquired a new branch and thus has customers in this new territory. They are interested in the default rate in their new territory. They wish to test the hypothesis that the default rate in their current customer base is higher than that of the new territory. They sample 200 files in area A, which is their current customers, and find that 20 have defaulted. In area B, the new customers, another sample of 200 files, shows that 12 have defaulted on their loans. At the 10% level of significance, can we say that the default rates are larger in the current customer base? Alright, the first step again is going to be to set up our null and alternative hypotheses. And we can look closely at the question here at the last statement. They say at the 10% level of significance, can we say that the default rates are larger in the current customer base? Now the current customer base was area A. This statement is going to correspond to the alternative hypothesis, and that would be equivalent to P sub A, the proportion of A, is greater than the proportion of area B. So the proportion in the current area of defaults is greater than the proportion in the new territory, which means that our null hypothesis must be opposite to that P sub A is less than or equal to P sub B. Alright, now that we have the hypotheses taken care of, we can move on to all the cells over here to enter in the relevant information. Just like before, we have the orangish pink cells where we're going to enter in information for the problem. So the first one is delta sub 0, which most of the time this is just going to be 0, which is the case in our scenario as well. The only time when this is not 0 is when we're trying to prove that one proportion value is larger than the other proportion value or different from the second proportion value by a specific amount. So, for example, if the question had said, can we say that the default rates are larger by at least 5% or something along those lines, then we would have a 5% in here. But in this case they had no such language, so we're going to leave that at 0. Alright, the second one says we need to enter the n sub A, meaning the sample size for area A, which was 200 files. N sub B was also 200 files in the new territory. X sub A would be the number of defaults in the first territory in the current customer base. That was 20. And X sub B would be the 12 that defaulted in the new territory. Alright, P prime sub A is going to be X sub A divided by N sub A. So that's equal to X sub A divided by N sub A. And P prime B sub B is equal to XB, X sub B, divided by N sub B. And then we also have PC, which is using both samples to find a proportion that kind of combines them both, and that's over here. That's equal to, and we need open parentheses for the numerator, X sub A plus X sub B, close parentheses, divided by, open parentheses again, N sub A plus N sub B, close parentheses, which gives us 0.08. Alright, now for the z-score, and that is this big old formula that we have right here. So we're going to use open parentheses for the top, which is P prime sub A minus P prime sub B. It also tells us to subtract delta naught, but since that was 0, I'm just going to leave that out. It doesn't make any difference in the equation since it's 0. We need to divide by, and we have a big square root symbol, so SQRT, square root. We need PC, so we'll click on PC, times, open parenthesis, 1 minus PC, close parenthesis, times, open parenthesis, 1 divided by n sub a plus 1 divided by n sub b. And then we have to close parenthesis one more time to close the whole thing. Press enter, and we get a z-score of about 1.47. Alright, and for the p-value, since this was a right tail test, we have to do equal to 1 minus norm.s.dist, open parentheses, enter the z-score, comma, and true for cumulative. And that gives us a p-value of 0.0702, rounded to 4 decimals. And we need to compare that to the level of significance, which was 0.10, or 10%, that was given right here. Alright, so 0.0702 is less than the level of significance of 0.1, which means that we are going to reject the null hypothesis. So our conclusion statement this time is that at the 0.1 level of significance, there is enough evidence to state that the current customer base has a default rate greater than that of the new territory. So there was enough evidence to state that the alternative hypothesis is more likely. So we rejected the null hypothesis and said the default rate is greater in our current customer base than in the new territory.